Just a minute, guys. We are going live. We'll see. Yeah, we are on live. Okay. Okay, guys. So let me start the discussion. Okay. So guys, can you see my screen? Can you guys see my screen? If yes, please let me know in the chat box. Am I audible? Is my screen is visible? Guys, can you see my screen? Let me check YouTube. We'll wait for another 2 minutes where others can join. Okay. So guys, good afternoon once again, everyone. Srikakulam joined and they left. I don't know what happened. Okay. Right. Okay. Good afternoon again, once again. So thanks for joining the class. I hope you can see me and you can hear me. If you have guys have any issues, please let me know through the chat box. Okay. अगर आपको कुछ problem है तो आप लोग बता सकते हो. Right. Right. So now moving forward. So today I have started halogen and derivatives. So why the purpose of starting this one? Because you guys already know that in your examination point of view from CBSE, halogen and derivatives plays very important role. You will get a question for sure. And for CET exam, for your state, CET exams, this chapter is also important. Let me give the outline of this chapter, what you have to read, especially in this chapter. So in this chapter, you need to know the IUPAC, how you are going to write. There are some special compounds like allylic and benzylic and their stabilities orders. You people need to know about it. And physical and chemical properties are must. How about their boiling points, melting points, structural stabilities, everything and all. And then okay. right? So another important thing in this is, very most important, substitution reactions. So substitution reactions are of two types, SN1 and SN2. And last but not the least, elimination reaction, E1 and E2. So today I'm going to plan these two, and the next day I'm going to plan to finish the elimination and substitution along with aryl alkyl preparation. Okay. So guys, let me start with the IUPAC naming. Basically, we know that the mono haloalkane can be called here. You are having one carbon, so that is monochloromethane, and chloroethane, one fluorohexane. All these things are there. Especially in your examination, aapko, like very most important, all you people need to know is what is geminal dihalide and vicinal vicinal dihalide. Geminal dihalide means where the halogens has been attached to one carbon. Okay, so where the halogen is attached to one carbon, then this is geminal dihalide. What is vicinal dihalide? If the halogens are attached to between two adjacent carbons. Two adjacent carbons, if it is attached, that is vicinal. And next, so trihaloalkenes, these all are the basic IUPAC names. You people all need to know. If you have read GOC, then you can understand how to write the IUPAC naming. What are the main principles of GOC? First, finding the principal chain, that is parent chain. Second, assigning the lowest number by checking the lowest sum rule. If there is a class, first point difference, then alphabetical order, then functional group priority. And whenever we are writing the IUPAC name, we check the prefix, root word, suffix. You know, prefixes are of two types, primary and secondary. That is cyclo group or secondary suffix prefixes. Primary, what are the substituents like halogens are methyl, ethoxy compounds, amines. These all are substituents. And if you come to the root word, what are those? Eth, meth, bro, pent, hept, hex, oct, non, like that. And suffixes are again two types, primary suffix and secondary suffix. So basically this, your primary suffixes are the functional group priority orders. You know, first acids will come, then aldehyde, then ketone. That the, you should know the order of the functional group priority to write the IUPAC name. So this is the brief idea about what are the things are happening in about IUPAC naming about any compound. Okay, so this is how you will structure the IUPAC naming. Now coming back to here, if you see numbering, if I'm giving 1, 2, 3, 4, 5, so that's why 2, 2, 3, 4. Tribromo, pent is the root word. Okay, and this is suffix. Alkane is the suffix here, and bromine is the prefix here. So like this you have to do. So first rule you people have understand, that is finding the parent chain and then assigning the numbering, finding the lowest sum rule. Now, so based upon that, now we are going to see how do you name the haloarene compounds. How do you name the haloarene compounds? Very most important haloarenes are bromobenzene. Okay, so if the benzene is attached with bromine, we call it as bromobenzene. And here you can see 2 chlorines are present on benzene. So that's why 1, 4 dichlorobenzene. These all are the IUPAC names. Then if I am talking about common name, then the name will changes. So if this is a main functional group and this particular position is ortho and this is meta and this is para. So then this can also call it as para-chloro-chlorobenzene. Commonly we can call it as para-chloro-chlorobenzene. If not IUPAC, numbering give 1, 2, 3, 4. At fourth position you are having chlorine and first position you are having chlorine. 2 chlorines are there, so that's why we are using dichlorobenzene. 1, 4 dichlorobenzene. And 1, 3, 5 tribromobenzene. And again, here the priority from the functional group priority, if you see, there is no other functional groups, only you are having substituents, bromine and chlorine. So how do you assigning number? Alphabetical orderly, bromine will get number 1, then C, B, then C. So then chlorine will get number 2. So that's why 1 bromo, 2 chloro, bromobenzene. Now you can see here, this structure is naphthalene. This structure is what? Naphthalene. So now in your examination, how many pi bonds are there, whether this compound is aromatic or not, how many resonance structure it can give, all you should know. So very simple, just remember the resonance structures of naphthalene. Number of rings plus 1 will give the resonance structures. So here 2 rings are there, so the total resonance structure will become 3. Examination, they will ask resonating structures of ring compounds. Like same like that, anthracene you are having 3 rings, so the number of resonance structures will be 4. Very simple. Jitna rings hai usko ek add kar do, then you will get the resonating structure. Right. So yeah. So Trisha is asking from YouTube, sir, when to use ortho para meta positions. So ideally, these can be used when we are using the common names. Whenever if I am giving the IUPAC name, you see the numbers. If I am talking in terms of common names, then you see the positions, ortho positions, meta position, para position. Okay. So just for common names. And again, you are having 2, 3 dichloronaphthalene. So this is naphthalene structure. And again, you can see here, this is very, very most important. Here, we are having biphenyl compounds, 3, 3, okay, 3, 3, 5, trichloro, 1, 1, biphenyl. Here you should write ethane, actually it was not written, okay, biphenyl ethane. So this one, if you are trying to name this particular compound, 1, 2, 3, for this one, 1, 2, 3, okay, 3 for this one and 3 dash you are going to get, okay, so then this one 1, 2, 3, 4, 5. So third position of this particular ring and fifth position of this particular ring, and if you can see third position of this particular ring, and you have given 1, 1. What is 1, 1? If you am considering this is a main chain, so if I'm giving number 1 for this one, so 1 dash you are going to get, and here if you are giving number 1, 1. So 1, 1 biphenyl ethane you are going to get, because 2 carbons are there, ethane. Okay, so that is what you can remember. So on the basis of hybridization, very, very most important, right? So now, can you tell me what is the name of this particular carbon? We call with a particular name for this carbon. What is the name for this carbon? Yes, when 4 different elements or compounds are attached to the carbon, this carbon is called as chiral carbon. What you are going to call it as? Chiral carbon. So if the carbon is attached to 4 different groups, here you can see chlorine, methyl, hydrogen. Let's suppose say here hydrogen is there. I'm just replacing with fluorine. So if 4 different groups are attached, then it is a chiral carbon. Then simultaneously, based upon the nature of the carbon, we can also give the names. So this is chloroethane, okay, and here you can see 2-chloropropane and 2-chloromethylpropane. IUPAC namings you can easily give. Very, very most important, allylic and vinylic, benzylic. So these are highly important for your examination point of view, because how to determine allylic is very most important. Yaad rakhna allylic ko kaise decide kare. This is sp2 carbon and this is sp2 carbon, because we are having how many bonds here? 1 sigma bond, and it is attached with 1 hydrogen. So that's why 3 sigma bonds. This is sp2. So again, this is what? sp3, and chlorine is attached. If the halogen is attached to the sp3 carbon, which is adjacent to the sp2 carbon, again I am repeating, if the halogen is attached to the sp2 carbon, okay, so ye carbon hai, so this is carbon which is sp3 ch2 cl, and this is sp2. This is sp2 carbon and this is sp3. If the halogen attached to the sp3 carbon and this sp3 carbon is attached to sp2 carbon, this particular group is called as allylic group. What we are going to call it as? Allylic group. So commonly we call it as allylic chloride. And if the chlorine is directly attached to the sp2 carbon, if the chlorine is directly attached to the sp2 carbon, we call it as vinylic group. We call it as what? Vinylic group. And same here, sp3 carbon, but this carbon is attached to sp2, but this carbon which is attached as sp2, that is a benzene. So that's why we call it as benzylic group. Very, very most important, allylic, vinylic, and benzylic groups. So these three groups you people need to remember. Once again, I will erase this one. Just see here very carefully. I will erase every this. Okay. So now see here allylic carbon. Allylic carbon is this is sp3 and this is sp2 and this is chlorine. So this is called as allylic chloride. This is called as what? Allylic chloride. And here chlorine is directly attached to sp2 carbon. So this is called as vinylic chloride. This is called as what? Vinylic chloride. Sir, but here you mentioned chloroethane. Here you mentioned 3-chloropropane. Yes, these are IUPAC names. These are IUPAC names. These are what? IUPAC names. What about this one? These all are common names. These all are what? Common names. Very, very most important. Same as benzylic chloride. What is this? Benzylic chloride. Chlorine is attached to sp3 carbon and this sp3 carbon is attached to benzene. Whenever if you are having like this, we call it as benzylic chloride. We call it as what? Benzylic chloride. Also IUPAC, what we call it as chloromethyl benzene. Very, very most important for your examination. Okay. I hope you guys understand this one. Right. Next. Yeah, so here I just mentioned and I will erase it once again. I just mentioned here. Yeah, so if the carbons are attached to sp3, that is allylic group. If it is sp2 attached, then it is vinylic group. So you can also see in aryl compounds. What are aryl compounds? Aryl compounds are cyclic rings. Aryl compounds are cyclic rings. Usually benzene को aryl compounds बोलेंगे हम, ठीक है ना? So very, very most important. Yeah, so based upon the hybridization, IUPAC and common names can be varied. Not IUPAC, especially common naming can be changed based upon the hybridization. Right. Now, I would like to see how many people can answer this JEE Mains question. I would like to see how many people can answer this JEE Mains question. Come on, I'm giving you 2 minutes of time. Okay, JNV Jalgaon, Rajkot, Warangal. Okay. I am giving you two minutes of time to solve this question and answer your give your response in the chat box. Okay, so Jalgaon and Warangal, what else other schools, and JNV, Rajkot, Gujarat. Please give your response in the chat box. Warangal people, yes, Rajkot is given. Okay, I got very interesting answer from here. We will see. We'll see here. Okay. Anyone? Multiple answer can also be correct. Multiple answer can also be correct. If the multiple answer is also correct, tell me the answer then. Rajkot, you have given correct answer, but there is another answer is also left inside. What is the other option? Tell me in the chat box. Yeah, correct. So I got answer from Trisha. That is 1-chloro-4-methyl-benzene. 1-chloro-4-methyl-benzene. The other name of this one is 4-methyl-chlorobenzene. 4-methyl-chlorobenzene. We can also name this one. This is more than one answer correct. 4-methyl-chlorobenzene we can also call, or 1-chloro-4-methyl-benzene. This is also we can give the name. Okay. So that is what you people need to understand. So this is homework for you guys. Try to solve this question and do it as a homework and please get back. So take the screenshot of it. Take the screenshot of it. Please do take the screenshot of it. Everyone. After taking the screenshot, please let me know through the chat box. Trisha, please let me know through the chat box after taking the screenshot. Guys, are you able to understand this one? Please do reply in the chat box. Okay. Yes. So this is homework for you. Next. Yeah. So general preparation of haloalkanes and how do you prepare the haloalkanes? So the preparation of haloalkanes is pretty easier. But if you see this first one, Lucas reagent, very most important. Lucas reagent is anhydrous ZnCl2. Okay, so HCl in the presence of anhydrous ZnCl2, this is called as Lucas reagent. क्या कहेंगे इसको? Lucas reagent. So this Lucas reagent will undergo like this. ZnCl2, it will become ZnCl2 and यहाँ से हमको क्या मिल जाएगा? You are going to get Cl minus. You are going to get Cl minus upon this particular reaction. Okay? So from this reagent, you are going to get a nucleophile Cl minus. Now here this is undergo carbocation. Okay, Lucas reagent will going to form a carbocation, and here you are having Cl minus. So both will going to form a bond as RCl. So very simple thing. All I want to say here is like Lucas reagent is able to form a carbocation, that is R plus. So whenever there is a carbocation is there, remember guys, very most important. Whenever there is a formation of carbocation, you need to check the stability. So in order to checking the stability, that should contain number of alpha hydrogen should be more hona chahiye. And second thing, it should be tertiary, secondary and primary hoga to stability of carbocation will takes place. So how we can make the tertiary, secondary and primary? By rearrangement. So by the rearrangement of the compounds also will get it. Best example if I am going to give you. So here you are having Cl. Okay, here you are having the Cl. So if I am using the Lucas reagent, okay, so not Cl here, I am giving OH here. I'm so sorry. This is OH. If I am giving the Lucas reagent, what will going to be the product? Ideally, here OH will be gone. So that will become what? Here you are getting the positive charge. And now here you are having Cl minus and you are going to get what? Cl here. You are going to get Cl here. But ideally, if you can see here, if you am writing in the open structure, that is CH3, CH3, CH2, OH. Okay, this is the structure. If I am using the Lucas reagent, what is the first step? CH3, C bond, CH3, H, and यहाँ पर आपके पास आएगा CH2 plus. Now you can see clearly. Now you can see it very clearly. So sorry, there is, yeah. So now you can see very clearly CH2 plus. What type of carbocation is this one? Please tell me in the chat box. What type of carbocation is this? Is this a primary carbocation or secondary carbocation or tertiary carbocation? What type of carbocation it is? Tell me in the chat box, guys. What type of carbocation is this? Yeah, Jane. Please do tell me in the chat box. What is the type of carbocation it is? Everyone, Rajkot, Jalgaon, Warangal. Guys, please do respond. If you are not responding, then I will unable to understand what is happening here. Right? Please do respond in the chat box. Okay. This is primary carbocation. What is this? This is primary carbocation because this is attached with only one carbon. Now you have to see whether shall I rearrange this or not? So if I am rearranging this hydrogen to here, now my new carbocation will be CH3, C plus CH3. यहाँ पर आपको क्या आ जाएगा? CH3. Now you can see this is your tertiary carbocation. Now you have to attack your Cl minus here, and at the end the product will be CH3, CH3, CH3 and Cl. Why like this rearrangement is taking place? Because of the stability of carbocation. So tertiary carbocation is more stable than secondary than primary. So rearrangement can be done in such a way that to get the stability of the compound. Rearrangement क्यों रहेगा? To get the stability of the compound. I hope everyone understand this one. Please do reply in the chat box. YouTube friends, please do reply in the chat box. This is primary because only one carbon is attached to this. So that is why. Please do respond in the chat box. Guys, please do respond. Just a minute, guys. Guys, please do respond. Okay, yeah. So I'm getting responses. Just a second. There is some technical error, so that's why taking time. Okay, so that is what you people need to remember regarding the Lucas reagent. Okay, now, so next one, let me erase this one screen, guys. Let me erase this. Yeah. So now another preparation is by using NaBr in the presence of H2SO4. NaBr in the presence of H2SO4. Right. So here in this case, we are having RBr and H2O. So directly preparation of alkanes, whenever you are having alkenes, you are directly keep a alkyl, you can directly keep the Br minus in the place of OH. Okay. So okay. Let me keep them mute. Yeah, right. Okay. So now next, if I am seeing here, okay. So that is PX3. That is phosphorus trichloride. If you are having compounds like this, phosphorus trichloride, or if you are having phosphorus bromide, tribromide, okay, phosphorus iodide, iodide compounds are that much easily available. So that's why I can say here is like we have to see only for chlorine and bromine. Chlorine and bromine can be possible from this. Okay. Right. Okay. So now let me answer you this one for this particular question. CH3OH. Okay. 3 times you have to take. You have to take 3 times in the presence of PCl3. Okay. You are going to get what? 3 times of CH3X plus H3PO3. How this is going to come? Very simple. You are having phosphorus and take 3 chlorines, chlorine, 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 and CH3OH and CH3OH and CH3OH. Okay. So just as simple as that. Okay. You can see from here. Okay. What is going to happen here? In this particular case, 3 chlorines are there. So these 3 chlorines and H PCl3 is there. And what is going to happen here? This chlorines will replace the OH. So you are going to get what? CH3Cl, and you are having 1, 2, 3. So 3 hydrogens are there and 3 phosphoruses are there. So that's why you are going to get H3PO3. So you can see here 3 hydrogens and 3 oxygens are there. So then this will become CH3PO3. That is nothing is much important here. I think you already know this one in your classroom. And next, POCl3. Okay, so POCl3, how you are getting this one? Let's suppose if I'm taking ROH, okay, plus here I am writing here Cl, okay, and PCl3, okay, and here I can take it as Cl. Okay, then now you can clearly say from here, break it like this and break it like this. Okay, I will erase and I will write nicely. There is a wrong step. So now see here, ROH PCl3 Cl. I am writing like this. Just break it. Just break it. Then you are going to get RCl plus POCl3 plus HCl. So preparation of alkyl halides is very easy in case of this. Okay. Next one, pyridine in the presence of SOCl2. So thionyl chloride. What is this SOCl2 is called as? thionyl chloride. What you are going to call it as? Thionyl chloride. So also we can also call it as what process? Darjan process. Also call it as Darjan process. Lucas reagent is Groove's process. Lucas reagent is Groove's process. Very, very important. And Lucas reagent is also used to check the turbidity. Lucas reagent is also used to check the turbidity. What is turbidity? Foam forming another. So tertiary will give first, secondary next, primary will not give. Okay. So tertiary alcohols will give more turbidity and fast turbidity. Secondary will give a bit lesser than tertiary. Primary will not give any turbidity. So ideally, to test the alcohols, Lucas reagent is helpful. To test the alcohols, Lucas reagent is helpful. If you are getting alcohol turbidity very fast, that is a tertiary alcohol. If you are getting after 5 minutes, that is secondary. If you are not getting any turbidity, that is primary alcohol. And thionyl chloride is the best method, the best commercial method for the preparation of alkyl halides. Why it is best method for the preparation of alkyl halides? Because later sulfur dioxide and HCl can escape as gases. So it is very easy. They can escape as gases. There is no byproduct is forming. So that is why thionyl chloride is best method for the preparation of alkyl halides. I hope everyone understand here. Is it clear to you all? Please let me know through the chat box. Please let me know through the chat box. JNV BED, Jalgaon, Rajkot, Sangli, Warangal, JSM, JMSS. Come on, guys, please do tell me in the chat box. Right? Guys, please do reply. I don't know why you guys are not replying. Is there any wrong from my side? Okay, let it be. If you are feeling shy not to reply, it's okay then. Right. Yeah. So now Darjan process is that. Now free radical halogenation of alkanes. So how the free radical mechanism is taking place. So very, very most important, guys. This is ideally very, very most important. So alkanes can undergo which mechanism? Free radical mechanism. So if here we are using sunlight or UV light, they can also give like this, sunlight or UV light in the presence of Cl2. Okay, sunlight or UV light in the presence of sunlight. Thank you, Rajkot team. Thank you so much. You are going to get a free radical. First of all, let me give the mechanism. Let me give the mechanism of it. So whenever you are having any alkane, let's suppose अगर आपके पास कोई alkane है, मान के चलेंगे इस तरह का आपके पास alkane है. So what is the first step you are going to get? You will get a free radical here. What type of free radical? You are getting one free radical, another you are getting free radical. Now you are having chlorine and chlorine. So both are shared. Okay, so the bond between them is covalent. So whenever there is a sunlight is passing, the chlorine and chlorine will get, okay, each one electron. So this is called as fish hook. This is called as fish hook. So each chlorine will get one electron, chlorine free radical plus another chlorine free radical. Now H radical and chlorine free radical both will remove as HCl. And this is the second step. Ideally, this is the first step and this is the second step. Third step will be chlorine free radical plus alkane free radical. Both will form a bond. Then you are going to get what? Chloroalkane. Okay, that is simply nothing but alkyl halide. So we can say that this particular mechanism is called as what? Free radical mechanism. So how to observe free radical mechanism? The observing of free radical mechanism is from where we have to observe from the sunlight or UV light. समझ में आ गया? Whenever there is any sunlight or UV light, you will undergo which mechanism? Free radical mechanism. So the first step is propagation. So the first step is propagation, and this one is process, and the third one is termination. So the third one is termination. So very, very most important thing. Okay, so this is what the mechanism of the free radical mechanism for the halogenation of alkanes. Okay, so I hope everyone understand this one. If you are clear, please let me know through the chat box. Right. Okay, let me erase this one. Yeah, I'm getting some response. Clear. Thank you, Jalgaon. Thank you, Rajkot. Now addition of hydrogen halides on the alkene. So now we are seeing the hydrogen halide alkene reactions. So whenever there is addition is taking place, hydrogen halide is there. So this is undergoing which mechanism? Markovnikov's mechanism. What is that? Markovnikov's mechanism. What is Markovnikov's mechanism? You might have read in hydrocarbons of your class 11, but if you forgot, no need to worry. So whenever there is any halogen, or any compound, H plus and will go where more number of hydrogen contained carbon, where more number of hydrogen contained carbon. So wherever you are seeing more hydrogen contained carbon, there this will go. But if it is a symmetry one, here you can see this is symmetry one, then hydrogen can go anywhere whatever it prefers. Now you can see, you can write this structure, write this structure CH3 CH double bond CH2. So now you are having HBr. So first you are getting H plus. Now I told you H plus will go where there is more hydrogen. Sir, here double bond is there. H plus can go route 1 and H plus can go route 2. So it can go into two routes. Either it can go for the number 1, 2, 3. So it can go for on the first carbon or it can go on the second carbon. So how do you decide which carbon it will go? So the carbon which is having more hydrogens, I hope you guys understand. The carbons which is having more hydrogens. Okay. So the carbon, some people are saying this. Yeah, thank you. Okay. So the carbon which is having more hydrogens. Here you can see two hydrogens. Here you are having one hydrogen. So the hydrogen will go which is having more hydrogens, then it will break the bond here. It will break the bond here. Here you are going to get CH3, CH. After breaking the bond, you are getting positive charge here and CH2. The hydrogen from this one will attack here. You are getting hydrogen here. So this is what. So the carbocation formation is taking place. This carbocation formation taking place. How it is taking place? H plus will go and attack on the more number of hydrogens. This is Markovnikov rule. In case if you are having H2O2 or in case if you are having any peroxide, and again HBr or HX is given in the presence of alkenes, then this is called as anti-Markovnikov rule, which is the reverse of Markovnikov rule. In this situation, in the case of peroxide, we also call it as Tarrasch effect. Okay, in place of peroxide, the H plus will go to less number hydrogen contained carbon, but without the presence of H2O2, without peroxide, okay, H plus will go to the more number hydrogen contained carbon. So that is the carbocation you are going to form. I hope you guys are clear with this. I hope you guys are clear with this. Okay, so now at the end, the final product I'll give you. Now at the end, the final product I will give you. Yeah, so CH3, CH double bond CH2 plus HBr, where this H will go here and the Br will grow at the middle. You are going to get CH3, CH, Br and CH3. So you can number here 1, 2, 3. So this is 2-bromopropane. You are going to get what? 2-bromopropane. I hope you guys understand this one. So here, I forgot to tell you, here you got two products. Among these two, which is major one? Major one is where the free radical is having more alpha hydrogens. Where the more alpha hydrogens are there. Here you are getting the free radical and here you are getting the free radical. So the total alpha hydrogens are here 3 plus 2. Here also H and H is there. So 5 alpha hydrogens are there here, and here you are having only 2 alpha hydrogens. So 2 alpha hydrogens are here. So the number of alpha hydrogens are more. The stability of the free radical will increases because of which effect? Hyperconjugation effect. Because of hyperconjugation effect, always the free radical, we can say secondary free radical is greater than primary free radical. Secondary say tertiary free radical. Here you can see this carbon is attached with 1 and 2 carbons. So this particular carbon is secondary free radical. And this carbon is attached with only 1 carbon. So then that's why it is called primary radical. Okay, this is primary free radical and this is secondary free radical. I hope you guys understand this one. Please let me know through the chat box. If you are clear with this, please let me know through the chat box. Please let me know through the chat box. Last 15 minutes left. Okay, so I told you in case of peroxide, yes. So in case of peroxide, if I told you H plus and Br minus, H plus will go where the hydrogens are less because you are having a peroxide. So now here you are having 2 hydrogens and here you are having 1 hydrogen. So then H plus will definitely undergo this carbon and Br will undergo under this carbon. So that's why you can see Br at the terminal end and H is at the center one. Okay. I hope you guys all are clear with this. No, phenyl if you are having, then it will changes. For phenyl also, in which case? In which case you are asking? You can unmute. Let me ask your doubt. So you can unmute yourself and you can answer it. Yeah. Can you ask loudly? I can't hear you. Just phenyl instead of alkene. Oh, in case if you are having phenyl group. So let's suppose if you are having, let me take some white screen so that your doubt can be cleared. Yeah. So now shall I explain like this? Let's suppose if you are having a compound like this. Okay. If you are having a phenyl group, so this is benzene group. So or else if I am taking here CH double bond CH2 like this, if you are having, so then this will become phenyl group. Then this will become phenyl group. So if this is the case, okay, if you are having chlorine here, HCl if I'm using HCl, okay, fine. If I'm using HCl, what is going to happen? Let me erase it and do it properly. Let me take black color so that it looks good. Okay. So now if you are having a phenyl group, what is phenyl group here? So this is benzene. Okay. CH double bond CH2. So then this will become phenyl group. Phenyl group, or you want what like this or what? If you are having a benzene, if you are having a benzene and you are having HBr, like this you are asking, or like this. This is A and B. Which case you are asking? In case A or in case B? Or do you want me to answer for both? Case B. Very good. So ideally, when you are having HBr, okay, so it will not undergo any particular reaction. Okay, but all you need to see here is like benzene. Benzene. So ideally, these electrons are delocalized. So let's suppose if I'm going to take here, okay, so here if you are getting negative charge and this double bond will be there, and here you are getting positive charge. So whenever you are having H plus and Br minus, so this H plus will go here and Br minus will go here. So this is ideally we prefer. But this is not that much easy to happen. Okay, this you are going to learn in the preparation of aryl halides. where the nucleophilic substitution takes place with the presence of any particular group. So this we are going to learn in the preparation of aryl halides. Okay, which mechanism it will undergo, you are going to get a pure clarity over here. Ideally, Markovnikov rule will exhibit only for the chain alkanes, not for the cyclic alkenes. Ideally, okay, in cyclic alkenes also it is possible, but for a benzene, it will not have much effect. Okay, so that is why what I am telling here is for the preparation of alkyl halides, we are using separate reagents. Okay, sorry, aryl halides. So to preparation of bromobenzene, let's suppose if you want to prepare bromobenzene, you will undergo another mechanism. That mechanism we are going to study. But Markovnikov rule will not be valid in case of this aryl, especially benzene compounds, aryl compounds, or else we can say that benzene compounds. I hope you guys understand. We'll study this one in the preparation of aryl halides. Okay, it will not be possible. Clear? We'll study this one in the preparation of aryl halides, but Markovnikov rule will not be valid. Markovnikov rule will not be valid. Is it clear? Yes. Yeah, in preparation of aryl halides, we will going to see this one. Okay. Very good. So now Finkelstein reaction, the other name for this one is exchange reaction. We can also call it as exchange reaction, where you are having this iodine and halogen will be exchange their positions in the presence of acetone. So acetone is a kind of helper or promoter. We are using as a dry acetone. We use dry acetone in order to avoid the moisture. If not, then iodine will undergo into the redox reaction. Why we are using acetone? If I am not using acetone, NaI is there, no. So that means Na plus and I minus. Then this I minus will further going to become as I2. So that means what? It is going to involve in oxidation. Okay. So that is the only case why we are using acetone, because acetone will help us to not the iodine to become I2. ऐसा नहीं होने के लिए, or else we can say that acetone will help the iodine to stop the oxidation. So that's why we are using acetone. So now you are having alkyl halide preparation. So that is simply exchange the positions. This X will be exchanged with iodine. That is Finkelstein reaction, usually used for the preparation of alkyl iodides. Alkyl iodide will be used. Next one is Schwarz reaction. Very, very most important. Next one is what? Schwarz reaction. Schwarz reaction is used for what? So Schwarz reaction is used for the preparation of, tell me, आप लोग एग्जाम के लिए पढ़े होंगे, YouTube friends and JNU BED team and Jalgaon, please respond in the chat box. What is Schwarz reaction is used for? Tell me in the chat box, guys. Schwarz reaction is used for the preparation of what? Yes, this is preparation for the alkyl fluorides. So alkyl fluorides ke liye, this will be going to use alkyl fluorides. So now look here, AgF CH3. So for the preparation of alkyl fluorides. Hunts-Dicker reaction for the preparation of alkyl bromides. Okay, Hunts-Dicker reaction for the preparation of, yes, very good Jalgaon team, for the preparation of alkyl bromides. So the other reactions are Hg2F2, okay, COF2. So you can also use all these kind of reagents for the preparation of alkyl fluorides from the Schwarz reaction. And Hunts-Dicker reaction is you are using what? Silver acetate. Silver acetate in the presence of Br2, you are going to get CH3, and AgBr precipitate you are going to get. AgBr precipitate you are going to get. I hope you guys understand this. So these all are the reactions and these all are the answers for those particular questions. So tell me guys, which of the following is a Schwarz reaction? Abhi to dekha humne. Which of the following is the Schwarz reaction? Please reply in the chat box. Which of the following is the Schwarz reaction? Tell me in the chat box. All my YouTube friends, please do reply in the chat box. Yes, option C is the correct answer. Schwarz reaction is used for the preparation of alkyl fluorides. Schwarz reaction is used for the preparation of alkyl fluorides. So option C is the correct. And this is Hunts-Dicker reaction. Hunts-Dicker reaction. Okay, and this is for halogen exchange reaction. This is also halogen exchange reaction. A and B are halogen exchange reaction or Henkel and Stein reaction. Okay. Now, this is homework for you guys. So this is homework for you. In which of the following conversions phosphorus pentachloride is used as a reagent? In which of the following reaction phosphorus pentachloride is used as a reagent? So यहाँ पर triple bond guys. यहाँ पर triple bond. Okay, so this is your homework. I hope everyone understand this one. I hope everyone understand this one. Please do reply in the chat box if you are clear with the thing. Please do reply in the chat box. Right? Yeah. Yes. Very good. Yes. Very good. Yeah. So next we will move to the next slide. Okay. Physical properties of haloalkanes and ये खत्म करके हम class खत्म कर देंगे. So just look here very clearly. As we are only engaging in Saturday, Sunday, I am going a bit fast. No need to worry. So boiling point orders will be depending upon the size and mass of the halogen. Higher the mass of halogen, higher will be the size. It required more boiling point. So that is why alkyl halide which is having iodine will have the more boiling point compared to other. So again, you people need to see if you are having a straight chain, if you are having a straight chain, and if you are having a branched one, if you are having a branched one, which will have more boiling point? Can anyone tell me in the chat box? You guys have read in your first midterm exam, but still we are recalling. The straight chain is there, branched is there. Let's suppose if this is A and this is B, which is having more boiling point, which required more boiling point. Tell me in the chat box, which required more boiling point. Guys, this you all need to know. This you all need to know. Yes. No. याद रख लेना, straight chain is required less branched. Straight chain is required more boiling point, and branched will require less boiling point because the surface area for the branched is less, but for the straight chain the surface area is more. More the surface area, boiling point will be more. Boiling point is directly proportional to surface area. So for the straight chain, the surface area will be more, but for the branched, but for the branch, it is boiling point is less. The boiling point is less for the branched one. Straight chain के लिए boiling point ज़्यादा होगा. So that is you people need to remember. So here you can see this is the straight chain. So that's why this is having more boiling point. And simultaneously, as the bond strength increases, as the size increases, the bond strength decreases. So that is why we have more bond strength. Okay, our bond strength are very simple. Next one, dipole moment decreases as the electronegativity of the halogen decreases. More electronegative is fluorine, then chlorine, bromine, and iodine. So down the group, dipole moment is decreases because our dipole formation depending upon the electronegativity. And solubility, alkyl halides are slightly soluble in water and soluble in organic solvents because they are polar in nature. They are polar in nature. So obviously alkyl halides are, all the alkyl halides are polar in nature, means delta positive, delta negative charge. So this positive negative charge indicate the polarity nature. So they are polar in nature. So that's why they can soluble in the water, okay, or in the organic solvents. So density, again, due to mass of the halogen down the group, size will increases, mass also increases, relatively mass by size or mass by volume increases. So that's why down the group density will be increases. So here you can see increase in the number of carbon atoms will increases the density. So these all are the preparation for the haloalkanes for today class. That's it guys. So try to answer this one, then we can end the class. Try to answer this one, then we can end the class. Okay. Try to answer this one and we can end the class guys. Carbon and halogen bond is stronger. Yes, D. Obviously, it is D. Okay. Obviously, it is D. Very good. So, the which chlorine atom is more electronegative? in the following. Tell me guys, which is having more electronegative? Very easy one. Inductive effect you can keep. Inductive effect you can keep. Okay, so here you are getting delta negative, here you are getting delta positive, and here you are getting delta negative, delta positive, and delta positive. So here option A will have the more electronegative on the chlorine atom because of CH3. Okay, so that is why I hope you everyone can understand more electronegativity for the chlorine. As the chain increases, the electronegativity also decreases. Okay, so that's it guys. Thank you so much for joining the class. See you in the tomorrow class. Bye guys. I hope you all understand this one. Please let me know through the chat box. आप सभी को समझ में आया होगा. चैट बॉक्स में मेंशन करो आज का क्लास कैसा लगा. वरंगल एट्लुंटा मनतोनी. I am from Khammam, so Warangal is very near to me. Jalgaon, also I know Jalgaon. That is in Maharashtra. Okay, Rajkot. Yeah. I came to Jalgaon. Nice. Thank you guys. Thank you so much. Thank you, Beat. Okay. Yeah. Thank you, Sangli. Thank you, Silvasa team. See you guys in tomorrow class. Bye bye.